Hello guys, welcome to Tech Refresh. In this video, we are going to discuss about one of the key concepts of object-oriented programming language. Yes, that is abstraction. What is abstraction in .NET? Before going to the concept of abstraction, we'll suggest you should have working knowledge of inheritance and the fundamentals of C# programming language. Nowadays, if you attend any of the job interviews or any client interviews, first they will start with the basics. They will ask the OOPS concept, and abstraction concept is one of them. So how we can define abstraction? The abstraction can be defined as a method that allows the programmer to display only the essential part, only those required features to the user, and without including the background details. That means it provides only those necessary details which is required to call the object's operations or methods. And how it does this? It achieves by hiding its implementation to the caller, which is called as abstraction. If you consider the technical terminology, an abstraction describes a contract but doesn't provide a full implementation. That means it only represents those necessary common behaviors or properties that its subclasses can utilize. So this is the main goal of today's topic. That is to handle the complexity and also providing a uniformity to similar types of classes. So let's have a look on abstraction examples. First one. When we log in to any social networking site like Facebook, Twitter, Instagram, or any secured website, what we'll do first? We enter our credentials, we enter our username and password, and then we get logged in or have access to their site. In this case, we don't know how they are processing the data or what logic or algorithm they are using here for login, because this information is abstracted or hidden from us since they are not essential to us. So let's consider another example. Nowadays, most of all the banks provide debit card that we can use to withdraw money from ATM or to make any purchase, whether it can be at any shop or it can be online. That doesn't matter. Let's say you hold a debit card and you are going for a cash withdrawal to any ATM machine. It doesn't matter which bank card you are holding or you are going to which bank's ATM. Here, the user only knows that in any bank's ATM machine, he or she has to first enter any of his or her ATM card, irrespective of any bank. Then the person has to enter the PIN code and then enter the amount which he or she wants to withdraw. And at last, that person gets the money. And that's it. In all the process, the user doesn't have to worry about which ATM card to choose or which bank's ATM to go to accomplish this process, whether to make any purchase or withdrawing of money. The user just simply follows the steps irrespective of any bank. So these two examples implies that abstraction is used either to provide common functionality to multiple unrelated classes or allows you to provide some default functionalities to child or derived classes. So how you can achieve abstraction? In .NET or in most of the object-oriented programming languages, abstraction can be achieved in two ways. Either you can use interface or you can use abstract classes, or you can use both. Because there are situations in which we need common or some default functionalities across the application. In such a case, we'll define a superclass which is nothing but an abstract class, or we can simply use an interface that declares the structure of a given abstraction without providing a complete or no implementation to its every method. So here we only defines a generalized form that will be shared by all of its subclasses, leaving it to each subclass to fill in the details or implement their functionality by their own. So first we'll talk about interface. Interface members are public by default. You don't have to specify any access modifier, even public. And interface may contain methods, properties, indexes, and events. Similarly, for abstract modifier can be used with classes, methods, properties, indexes, and events. Or we can say an abstract class can contain abstract methods, abstract properties, abstract indexes, and abstract events. Then we'll discuss about the features of interface. Interface members cannot have any access modifiers as they are public by default, and even we cannot specify any access modifiers even public. One class can inherit from multiple interfaces, so multiple inheritance is possible with the help of interfaces. Interface cannot contain constants, constructors, destructors, static members, since interface doesn't provide any type of implementations. Even they cannot contain variables. Yes, they cannot contain variables, but they can contain properties. One interface can inherit from another interface or more interfaces. In that way, you can extend an interface. So let's discuss the features of abstract class. First of all, abstract class cannot be instantiated, and its main purpose is to use it as a base class. Abstract members must be implemented by its derived classes or concrete classes, and you can use the keyword override while implementing abstract method in derived classes. You cannot use sealed modifier in an abstract class declaration because it will prevent an abstract class from being inherited. However, abstract class can contain sealed methods. Abstract classes can contain constructors and destructors. Abstract class can have concrete and abstract methods, but to create an abstract class, at least one abstract method is required. So why you will consider using an interface than abstract class? So when you want to provide common and useful functionality to unrelated classes, because when one class inherits from an interface, it has to implement all its members. In that way, all the classes that inherit from that interface will have those similar kind of functions or methods in common. When you want to create loosely coupled pluggable components, because here classes are not dependent on one another, it actually depends on interfaces. So an interface, as the name describes, is only responsible for telling what the class needs. It defines the rules, also known as contract, which the class must implement. That's why interfaces are a powerful tool to use for decoupling, where classes communicate through interfaces rather than concrete classes. When we want to introduce polymorphic behavior to a class, since we can have one or more classes that implements the one interface or multiple interfaces that can be implemented by one class. So when you will consider using an abstract class. First of all, abstract class simplifies versioning because one can add new properties or methods or new members to an abstract class without breaking the existing code. Here, all inherited classes are automatically updated with the change because those new properties or new methods would be available to its inherited classes. Abstract classes allows to partially implement a class because it can contain both abstract and concrete methods. So concrete methods can be used to provide default functionality, where abstract methods provide common functionality to the inherited classes. So what are the common design guidelines for interface? Instead of adding multiple unrelated tasks to a single interface, always split it up to multiple interfaces so that they will contain unrelated functionality. In that way, you can keep your interfaces focused. Never add all the methods into one interface. Try to categorize or try to make your interface more specific to related functionality and separate those methods into more than one interface. So in that way, it will become more maintainable or more useful. As I said in the previous point, never create an interface specific for a class. Create an interface related to functionality. So, an interface should define the common functionality that can be implemented by the classes of different modules or subclasses. Never misuse of creating interface for every reason. Otherwise, it would be very difficult to maintain it. Because if you will change something in an interface, then you will also have to make changes in the inherited classes, which may break the code or add extra burden. So these points are facts to be avoided or to be taken care of if you are planning to design interface in your software programming. So now we'll discuss about the common design guidelines for abstract class. First of all, never define public constructor for an abstract class because abstract class cannot be instantiated. Instead of public constructor, use protected constructor or internal constructor for an abstract class because protected constructor allows the base class to do its own initialization when subclasses are created or called. Similarly, by using internal constructor, we can limit concrete implementation of the abstract class to the assembly defining the class. If you are creating an abstract class, it shows to the user or programmer that the sole purpose of this class is to be inherited from by the subclasses. In that way, it clearly communicates to the user, or it gives the indication that all abstract or virtual methods has to be implemented by the derived classes. In this way, it provides common functionalities across the subsystem. Now we can review what we have covered. Here we will compare abstract class with interface and basic difference between them. An interface doesn't contain any implementation. However, an abstract class may contain both abstract members and concrete members. One class can inherit from multiple interfaces. However, it's not possible for abstract class. It's a one-to-one relationship. One class can inherit from one abstract class only. Abstract class can contain constructor, where interface doesn't contain constructor. Abstract class can contain static members. However, interface with static members is not possible. In the interface, everything is public by default. So, you don't have to specifically add any type of access modifier in an interface. However, abstract class can contain different types of access modifiers. Abstract class can be fully, partially implemented by its derived classes. However, interface should be fully implemented by its derived classes. And the last point, in terms of performance, an abstract class can have concrete methods which has their own implementation. And for its abstract methods, it has reference to its implemented classes or derived classes. So performance is comparatively faster as compared to that of interface. On the other hand, the performance of interface is slow because it requires time to search actual method implementation in the corresponding class. Thank you for watching this video. If you have any question, don't forget to comment below. And yes, in our next video, we'll cover the practical aspect or example of interface and abstract class. So please like, share or comment. And don't forget to subscribe this channel. Thank you very much.